welcome to True Projects. In this video, we are going to explain about the project which is empowering glioma prognosis with transparent machine learning and interpretative insights using explainable AI. So before getting into the execution, first let's understand what is the project about. So what is glioma? Glioma it is one of the most common cancer types that affects the central nervous system starting from glial cells in the brain or the spinal cord. Now, these glial cells, they are basically the support system for nerve cells, but when they start growing abnormally, that's when things go wrong. So, glioma can vary severity. They can vary in severity. Some are manageable, while others like glioblastoma, that is glioblastoma multiforme, are extremely aggressive and they can spread very quickly, making them tough to treat. So these tumors, they mess with how brain functions by either pressing against healthy tissue or growing into it. This leads to bunch of symptoms which can vary depending on where exactly the tumor is located. For instance, a person might experience frequent headaches, memory problems, or even changes in personality and also the behavior. In some cases, it affects speech or vision, and the cognitive ability may decline over time. So the impact really depends on which part of the brain is affected, and the severity increases if the tumor grows rapidly, like in the case of GBM. Moving on, diagnosing and predicting this glioma is really tricky. One of the main reasons is wide range of tumor types and their unique genetic and molecular features. Traditional methods often have hard time in pinpointing how severe the tumor is and forecasting any potential complications. This can make it tough for doctors to develop effective treatment plans and early on. However, we have some techniques that are artificial intelligence and machine learning algorithms. So these are used in detecting the glioma. These technologies can analyze complex data much more effectively than the traditional methods by looking at the things like genetic markers, demographic information, and patient's medical history. AI and ML can help predict how the tumor might behave and what the likely outcomes could be. This means we can get more accurate insights into glioma, which ultimately aids in better treatment, planning, and patient care. So, in this project, we are creating a reliable diagnostic model that can help detecting glioma by thoroughly analyzing different types of patient data, including medical records and genetic markers using machine learning techniques. So here we use some mix of machine learning and deep learning techniques. So in this project, we are using the mix of machine learning and deep learning approaches. So these techniques they make predictions about whether a tumor is present and what the likely outcomes for the patient could be. The models we are including are random forest, decision trees, logistic regression, KNN, SVM, CAD boost, light GBM, XGBoost, ANN, and CNN. To make sure we are focusing on the most relevant data, we are also applying some feature selection techniques, which are Pearson coefficient, PCA, and mutual information. So we will be extracting important features using these techniques. And then overall, this system is designed to be a practical tool for healthcare professionals, allowing for early diagnosis and personalized treatment planning. By providing more accurate insights, we hope to enhance the clinical decision making and ultimately improving the patient care. Moving on, as an extension of this project, to further improve the accuracy, in this project we are incorporating voting classifier as the extension. This is an ensemble technique. So this approach combines predictions from various individual models, which helps us to generate a more robust and accurate final prediction. Essentially, it leverages the strengths of each model to improve overall performance. On top of that, in this project, we are building front end using Flask framework. So we are building front end using Flask framework. This will allow users for user testing, making the tool more accessible to healthcare professionals. And we also include user authentication to ensure that everything is secure, giving users peace of mind when accessing the system. This combination aims to enhance both the accuracy of our predictions and the overall user experience. Moving to the implementation of the project, we have followed the steps of flow of work to implement the project. So let's understand these steps. First, we have imported the required packages. Then we explored the data set, which is Glioma grading data set. So we loaded this data and we did exploratory data analysis to understand the structure. Then we did some data pre-processing. So we have removed duplicate data, we dropped null values, and we have converted categorical data into numerical using this label encoding technique. And then we have visualized the data using sample outcome graph, which shows the distribution of the data, distribution of the target class. Then we have appended all the features to X variable and target to Y variable. And we selected important features using PCA, Pearson correlation matrix, and mutual info individually. Then we split the data into train and test sets. So train is used to train the models, test is to evaluate the models. Then we build all those models. After building, we fit all those models with the data set, with this feature selected data set. So all the models are built on these feature selected values. And here we have compared all those models using this accuracy, precision, recall, FN score, AUC, MCC, and Jacquard score metrics. So these metrics are used to evaluate all the models built. And we have compared all those models using the graphs. And we have developed front end using Flash framework. Then we have, in the front end, users, they will be able to give the feature values. So that feature values will be pre-processed at the back end and it will be fit with the train model and final outcome will be displayed through front end. Moving on, these are the algorithms used in the project. So these are the total algorithms used in the project to detect the glioma, to classify the glioma. So this is the extension model that has performed well among all the models built. So we have used it for predicting the glioma in the front end. So this is all about the theoretical part. To execute the project, to implement the project, we need basic requirements, which are hardware and software. So coming to hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. And coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3. Front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So now let's execute. To execute, we need to open the code folder which contains source code files. So these are the source code files in the code folder of the project. Let's understand each of them. How will they be used in the project? So coming to the data folder, these are the data sets that are used in the project. So let's open this. So this is the data set used in the project. Minimize it. So this is the process data. Close this. This was the original data and this is the process data. Get back. And this is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal of the project. And this is the templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is app.py file. This .py file contains the information related to front-end logic of the project. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And this is the model file which contains the algorithm information. This will be loaded into the project code during runtime. And here we have 4 notebook files. So these are the Jupyter Notebook files which contain the combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. So if we take this PCA feature selection notebook file, in this file, from the data, PCA technique is used to select the important features. After selecting important features from that, it will be trained on all the models. Accordingly, other notebook files also. So here we have used Pearson correlation to select the features and all the models will be trained on Pearson correlated features dataset. And similarly, mutual info and this imported FS also. Moving on, here we have signup.db file. This file is a database file that is used to store the user information. And here is the sample file in which we have the test cases that will be used in the front end to detect the glioma. So these are the test cases that will be used in the front end to detect glioma. So close this. Now let's execute. So copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now open Anaconda prompt. So using the command cd followed by the space, paste the copied path and now click on enter. This will change current directory to the code folder's path. Now we need to compile app.py file. So give the command python space app.py and now click on enter. This will compile app.py file and it will execute Python script and check for syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So this is the local host and this is the port. So now copy this local link provided by the Flask framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Paste the link here, click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So we need to register first. Click on register and enter all the registration details if you are registering newly. I have already registered. I have an account in it, so I'll directly sign in. So click on sign in. Give your username and the password. Now click on login. We have logged in successfully and we are redirected to prediction page of the project. So here you can see parameters, right? So these are the parameters need to be given as input. Based on the given parameters, we will be getting the prediction. So let's understand them first. So first we have is IDH1. It is a gene that encodes an enzyme involved in cellular metabolism, and mutations in this gene are commonly associated with certain types of gliomas, influencing tumor behavior and patient prognosis. Coming to age at diagnosis, this is the age at which a patient is diagnosed with glioma can impact treatment decisions and overall survival, as tumor type and aggressiveness can vary significantly with age. Coming to PIK3CA, it is a gene that encodes a protein involved in cell growth and survival. Mutations in this gene can contribute to cancer progression and are often observed in gliomas. ATRX, it is the gene that plays a role in the chromatin remodeling. Mutations in ARTX, ATRX can be indicative of specific glioma and subtypes and have implications for tumor behavior and prognosis. Coming to PTEN, it is a tumor suppressor gene that helps regulate cell division and survival. Loss or mutation of PTEN is frequently seen in gliomas and it is associated with more aggressive disease. Coming to CIC, it is a gene that is involved in transcription regulation. Alterations in this gene can be linked to glioma development and may influence tumor characteristics. Coming to EGFR gene, this is the gene encodes the epidermal growth factor receptor, which, when overexpressed or mutated, it is associated with the tumor growth and poor diagnosis in gliomas. The last one we have is TP53. It is a well-known tumor suppressor gene that plays a critical role in preventing cancer. Mutations in TP53 are common in various cancers, including gliomas, and that can affect patient outcomes. So this is all about the parameters we need to give the input. So for that, open the sample file. So let's give the inputs. So let's use the first test case. So here we are supposed to enter the first value, that is IDH1, which is 0. Age at diagnosis is 82.32. PIK3CA is 0. ATRX is 0. PTEN is 0. CIC is 0. EGFR is 0. TP53 is 0. Now click on predict. So based on the given input, now we will be getting the prediction that patient is suffering with the TCGA GBM brain glioma. It means that it refers to glioblastoma multiforme. It is the most aggressive brain cancer known for rapid growth and poor diagnosis. It is the severe stage where patient has very aggressive cancer cells. So it is glioblastoma multiforme. Now let's try with the other test case. So click on prediction. So let's try with this third test case where IDH1 is 1 and the age at diagnosis is 31.75. PIK3CA is 0. ATRX value is 1. PTEN is 0. CIC is 0. EGFR value is 0. And TP53 is 1. Now click on predict. So here we got the prediction that patient is suffering with TCGA LGG brain glioma. It represents low grade gliomas, which are slower growing brain tumors, which are generally better prognosis, which means these this glioma cells, they can be treated in early and they can be get cured. So let's try with the other test case. So click on prediction. Let's try with this test case. That is the 10th test case. So give the IDH1 value, that is 0. Age at diagnosis is 36.3. PIK3CA is 0. ATRX is 0. PTEN value is 1. CIC is 0. EGFR value is 0. And TP53 is 1. Now click on predict. So here we will get the prediction that patient is with GBM, brain glioma, that is nothing but glioblastoma multiforme, which is a severe level of glioma. Let's try with one more test case. Click on prediction. So let's try with this test case where IDH1 is 0. Age at diagnosis is 59.84. PIK3CA is 0. ATRX is 0. PTEN is 0. CIC is 0. EGFR is 0. TP53 is 0. Now click on predict. And here we got the prediction that patient is suffering with TCGA GBM brain glioma, that is nothing but glioblastoma multiforme. Now let's try one more test case. Click on prediction. Let's try with this test case. That is the 16th test case where IDH1 is 0. Age at diagnosis is 52.09. PIK3CA is 0. ATRX is 0. PTEN is 1. CIC is 0. EGFR is 1. TP53 is 0. Click on predict. So here we got the prediction that patient is suffering with TCGA LGG brain glioma, which is the lower grade of glioma. It is slower growing brain tumors with generally better prognosis. That means it can be cured early. Now let's check with the graphs. So let's click on imported features first. Before that, we need to discuss one more thing. So we have selected features using different techniques. One is PCA, PC, that is Pearson correlation, and mutual info. So we have trained all the models on all the individuals feature selected techniques. So first, let's check with the PCA feature selection technique. So click on PCFS. So here we have sample outcome graph where on x-axis we have 0 and 1 and on y-axis we have the count of each class. So 0 refers to one type of class and 1 refers to another type of class. 1 is the GBM and 0 is the brain glioma, that is TCGA LGG brain glioma, and 1 is TCGA GBM brain glioma. If you observe, LGG brain glioma is more than the GBM brain glioma. Moving on, this is the accuracy score graph where on x-axis we have the accuracy scores and on y-axis we have the algorithm names. And here this is the precision score comparison graph, and here we have the recall score comparison graph. This is the F1 score, this is the AUC, this is the MCC, and this is the Jaccard score. Now let's check with the other feature selection graphs. So click on that and click on PCAFS. So these are the features selected using PC, that is Pearson correlation. So this is the same sample outcome graph, and this is the accuracy comparison graph. And here we have the precision comparison graph. This is the recall score, this is the FN score, and this is the AUC score, MCC and Jaccard score graphs. Let's check with the other feature selection, that is mutual info. So click on MIFS. So this is the same sample outcome graph. This is the accuracy comparison graph where on x-axis we have accuracy score and on y-axis we have all the algorithm names. If you observe, voting classifier, the extension is having the highest accuracy than any other model. And here we have the precision score. Similarly, we have recall score, FN score, AUC score, MCC, and Jaccard score. Now let's try with the last file. So that is imported features, important features. So click on that. So here we have selected features based on the reference paper. So here we have selected features based on the reference paper and we have trained the algorithms according to that. So this is the accuracy score comparison graph. And here, if you observe, voting classifier is having the highest accuracy. This is the precision score, recall score, FN score, AUC, MCC, and Jaccard score. Now click on log out. In this way, by entering the required parameters, our machine learning models, they will be able to correctly identify the brain glioma grade, that it may be LGG brain glioma or GBM brain glioma, that is nothing but glioblastoma multiforme. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.